Hi, my name is Yash. I'm a rising sophomore at Leland High School. And for my first modification, I decided to add a pan tilt servo mount to my robot. There's one servo here that pans, moves left and right, and one servo here that tilts, moves up and down. And this adds an extra up and down degree of freedom to the robot so that it can track the ball on the vertical axis and can even track the ball while stationary, making it more versatile. When you can see the main file, you'll see the camera set up and the robot will be ready to start tracking the ball. But I have added an additional servo mode where the pan tilt servo mount will move to center the ball in the center of the frame. So how it works is the servo takes in a PWM or pulse width modulation signal from 500 to 2500. These are kind of just digital waves that have space between them, and depending on that space, the servo knows what angle to turn at. So my robot remembers the last angle the servo was at and increments that either up or down to move the servo left or right, up and down to center the ball in the frame, and moves it until the ball is around in the box of 20 by 20 pixels around the center. Some challenges I had while building this was servo chatter. These servos are not very high quality. They're very small and they're made out of plastic. So they had a lot of chatter. They would jitter back and forth. But I used the PyGPIO library, which is a library specifically designed to reduce servo chatter. And after using this library, the servo was much more smooth and it was much easier to work with. If I had to start this project all over again, I would go for a more machine learning approach. I would use a Coral dev board or a Google Coral USB accelerator to kind of accelerate the machine learning process and use a TensorFlow Lite model with edge impulse to make it so that it's not just a ball tracking robot, but an object detecting robot as well. Thank you.